Morning, Khalid. Or Khalid? Or
Good morning. Khalid, yeah.
Khalid, yeah. Let's see if I can, how many of you all I can see here. Aha, good. There's a good number. You all can hear me just fine, I suppose?
Yes. Yeah.
Okay, so you'll get used to the routine here, I think pretty quickly, but at the beginning of each class, as you might recall, there is a participation grade. And so at the beginning of each class, I will ask for volunteers. That is what participation is based on. If for some reason someone cannot participate for whatever reason, internet issues, so on, they need to email me so that I know in advance that I need to find some other way for them to make up for their participation grade. So if you don't email me or send me anything, then I will assume that you, like all the others who haven't emailed me, are part of the participation grade. And so you should try to volunteer. Volunteering means being willing to talk to me, to discuss topics, ask questions, and to turn on your camera so that I can see you and others can see you. So just to repeat, if you cannot do that throughout the course, then you should send me an email explaining why that is the case, and then we'll come up with an alternative solution. Okay, so let me start by taking volunteers. I'll take up to about 6 volunteers, or depending on how excited people are to participate, and sometimes more. Who would like to volunteer? Please, obviously everybody can't just yell out at once, so please, please take your time, be patient with your colleagues. Who would first like to volunteer?
You mean volunteer to explain what we had to read for today?
So in order for this not to become a session where you all just sit there quietly, I like to have people to talk to. Volunteering means, I mean, you could volunteer even if you haven't read the material, but I would prefer you to obviously have read the material. But what I will ask you questions. You can ask me questions. You will just be an active participant, and you will turn on your, just as if we were in a live class, right? Essentially, I'm going to take, since I can't have all of you turn your cameras on all at once, it would be a mayhem. I'm going to ask each time a small group of you as if we have a small class of about 6 people. Does that make sense?
Yeah.
Cool.
Yes, sir.
Would you like to volunteer?
Yeah, I guess so.
All right. Sounds like you're already doing it. Who else? Who's next?
Professor, I would like to volunteer as well.
Asma?
I would like to volunteer. Asma.
Yeah.
Yeah.
Got you. Who else? This is where I learn who the students are that really want to do well.
I have no problem. I can volunteer.
Abdul Al-Hajar. Anyone else?
I wouldn't mind volunteering as well.
Okay. How do you say your first name?
Kinda.
Kinda, so it's that simple.
Yeah.
And I can also volunteer.
Raymond. That's a name I'm familiar with.
I'll also volunteer.
Sarah. Now you're all starting to get some confidence, huh? Okay, that's all I need. If there are some people who for some whatever reason haven't gotten to volunteer as we go through the course, and there's some people who have volunteered absolutely every time, which will happen. I'll always, you know, if you don't get in right away, just say something. I can add you to the list. So everybody will have an opportunity. It's not a competition. Well, it kind of is, because at the end of the course, I of course will. I'm a very holistic grader. So I look at your performance on individual assignments, but also your interest in the course, your participation. And so even for things that there may not be technical scores for, that certainly I have that, bear that in mind when I'm making decisions about, is this a B+ or an A-, or where does that person fit on the scale? That absolutely has an effect. So participation will be important for that, I think. Okay, so first of all, just again, this is only our second session, so I want to kind of talk a bit more generally, and we'll still have to deal with some of the technical things to ramp up. Last time, or the last couple of times, I tried to go through all of the technical, things that had to be done and all the websites and passwords and whatever. And if I do that all at once, that's a bit too much, I think, for students. So I'm going to kind of introduce things one at a time. First of all, so last time you essentially got introduced to the website, and you were able, yes, you were all able to watch the videos. Yes.
Yeah. Yes.
Yes.
And to take the quiz, as I can see. Yeah. If any of you had any trouble with that, email me and we'll work it out. How was that? How did that makes pretty good sense? In the future, that's how we will do quizzes. They will be through that same application with the same room name. How did that seem fine to you? Was that a nice?
Yeah, it was pretty straightforward.
Pretty straightforward.
Yeah, same here.
So
It was easy.
Yep.
Good.
I just have something to say.
Excuse me?
I just have something to say
Okay.
about the website. Every time I came to log in or like to enter the website, it would take forever to load. And then I'd have to like restart my computer and then enter the website again for it to load.
Did
It
you
would like
try it
take hours for it to open.
Did
So
any,
I don't know what like I tried on my phone as well, and it's the same thing.
were you the one who emailed me about this?
Yeah.
It must be something with your internet connection. I don't know. Is it generally poor? Well,
I don't know because
go ahead, and then we'll.
it works, like everything works fine, and I'm like not in Lebanon, I'm outside the country, so I have pretty good like internet.
I don't know
know
why
what the
only
issue is.
you would be having a problem, but we'll talk about it. Okay, so send me a separate email again, and we'll see what we can do. But I don't know how to completely not use my main.
No, yeah, I know, it's fine. It's fine, okay.
But we'll figure something out. You can always email me, and I can email you the information. You have access, pretty good access. All the videos are on YouTube, so they don't need to be loaded through the website.
All right, okay.
So I can send you links and stuff. Okay. So that was straightforward. That's good. That's the way it's supposed to be. The second thing, and this should also be just really simple and straightforward, and I'm going to explain it to you now. You can all see my screen, correct?
Yes.
Throughout this course, you're going to be sharing with me your annotations, which I'm going to talk about in a minute. Those files are not enormous, but the best way to do that. Also, later you're going to share with me the little projects that you do, and so on, like the video project at the end. And the way you will share all of that with me is through a Dropbox folder. Some of you, I imagine, already have Dropbox because it's very useful. Some of you have it. Yes. Any of you? Raymond, do you have Dropbox?
Yeah.
Yeah. Some people have it. Okay.
Yep.
So if you have Dropbox, that you constitute one group of people who know what I'm going to be talking about, but you have there's one special thing about that. I'll tell you in a minute. And if you don't have Dropbox, I'm going to explain everything. It'll be very, very simple and straightforward. Dropbox is a program that you download and install on your computer and will allow you and I to share a folder such that if you put something in that folder, I will see it within the next 10 minutes. It will show up on my computer. I don't even have to download it. It automatically downloads onto my computer. Meaning, you should put the things in there that you want me to see and don't put anything in there you don't want me to see, because I will see it. Yes. So don't use it as your junk folder. Now, the same thing is on my side. I put anything I put in there or any changes I make to those files in the folder will all automatically upload to your computer, right? So you will see them as well. One thing about Dropbox, and I'll just mention this on the side, it's because it automatically uploads and downloads. If you have a very poor connection, you might want to pause it sometimes because it might just be running there in the background. That's a side note. But okay, so here are the two cases. I'm looking at on my screen here. You can see it. I will also email this to people. So case one, if you are those people that already have Dropbox, this is what you need to do. So if you already have Dropbox, you need to send me an email to courtney.fugate@gmail.com. That is my preferred email for communications. The AUB email, it has lots of problems, so I prefer it to go through my Gmail. So send me an email. In that email, the header should be your name, and within the body of that email, you should have your name followed by the email address to which your Dropbox is linked. It's very important. If you send me, for instance, let's say you have your Dropbox linked to your Gmail address and you have a Gmail address, but you send me your AUB email address, then when I share it with you, there will be immense problems. All right, because then it will try to install a second Dropbox folder on your computer and require you to uninstall your previous Dropbox folder, and it'll just be a mess. So make sure that the email that you send me is the same one that is associated with your own currently installed Dropbox. Any questions there? I'm guessing not. No. Case two, you do not have Dropbox, right? If you do not have Dropbox, you need to go to dropbox.com, install the program on your computer, and then sign up with it. It's free, doesn't cost any money, with any email address you like, right, as your email address. Then you do exactly as in case one. You send me an email with your name in the header, and within the body of the email, your name and the Dropbox and the email address to which it is linked, right? After you do this, so by the end of the weekend probably, you will receive an invitation to share a folder with me in both cases, right? You'll join that folder. When you open up, so those of you who have Dropbox already know this, but those of you who do not, do not. When you finish all of this, there will show up on and I'll show you mine. So here's my file folder system, right? And there's something called Dropbox. This will just automatically show up in your file system. And under that will show up a folder with your name on it. That's our shared folder, okay? So that is, and now, once all that is finished, you should place your reader, your PDF of your reader in that folder, right? Now, what that means, and so I know this is self-evident to some of you, but other students have problems with it because they think, well, now what do I do? How do I upload stuff to that folder? And do I need to upload it every time I change my file and so on? And the answer is no. As long as you keep your PDF file in that folder, you always open it from that folder, and you always save it, right? And it's being saved back to that folder, then all those changes will be visible to me. Okay, so essentially this is nice because once it's set up, you don't have to do anything to turn in your annotations. I can check them whenever I want, and I will check them periodically. So that's very, very convenient for both of us. Any questions? That's the technical. Hopefully that was very clear. Any questions? Don't worry if you have a question. Just ask it. Anyone?
Can I share my screen, and could you show us how getting started works? Because I have it installed. I just never set up a folder.
Well, then what you have to do is just send me the email and wait for the invitation.
Oh, okay.
And then it will install once you share the folder, it will create the folder for you. Right?
All right.
All of that will be
Thanks.
taken care of. So if you have trouble, then we can share. Okay, so that hopefully that's
Okay.
any other questions? So just be patient till the end of the weekend. If you're having problems, then we'll take care of those. All right, once you get that invitation. Okay, good. So I should, after this class, be receiving an email from each and every one of you after, either immediately if you already have Dropbox or once you've installed it. Okay. Okay, no further questions. All right then. Now, I'm sure many of you want to know about these annotations, right? What is this all about? One thing I can tell you is if you go to I gotta find which browser I'm using here. If you go to our website and you look on the side here, there are other types of videos sometimes I put here. The first two are for fun. I would encourage you to watch them. The third one is about some issues that some students have had in the past about saving their annotations in Adobe Acrobat. The final one are tips on how to annotate, right? So if you click on that, it's not a very long video. I give you some further information about annotating and what to do, right? So that's not, we're not going to watch that now, but there's something there. Now I'm going to, nevertheless, I'm going to say some things right now. So part of your grade are these things called annotations. Let me say a word about annotations in general. You guys, none of you are new to this business of going to the university, right? So I would expect that many of you already do annotate the text that you read. If you don't, you should be doing so. It's often something we don't do because we're a little bit lazy, but it's one of those things that if you put in a little bit of effort, actually the lazier people will like it more than the other people, right? Because it's one of those things, it takes a little bit of effort, but once you do it, it saves so much effort. Not only does it do that, but it makes you feel smart at the same time. When I was doing my PhD, for instance, one of the books, you're going to read a lot of books for a thesis or a PhD or whatever. And if you just read that book, Leibniz, I read a book by Leibniz called The Theodicy. It's about 340 pages, pretty small text. If I just read that book, when I was done, how would I, suddenly I'm writing and I think, here's a point where I should refer to that thing that Leibniz said, right? And then I look over and I've got 340 pages to look through to try to find where that thing is that Leibniz said, right? And so I get into the index and I'm looking for keywords. This is going to take a long time. And there may not even be any keywords that take me exactly to the quote. If I'm very lucky, I'll dig up an electronic version, but probably not. That time I couldn't. So what did I do? As I went through the book, I marked those things that were important. Things that when I read them, I said, now this is probably something I'll want to be able to look at again in the future. And no one else, particularly because often when you're reading, you're not reading to know everything in a book. Almost never, you can't. I mean, you usually read a book with a purpose. There's certain things you want to look at closely. And so as you notice those things, you are doing that work when you're reading it of noticing what's important and what's unimportant. And if you don't mark it, you lose all that work, right? So when I was done, this is one of the most, this is why I tell it, because it was such an impression on me. I went through, I marked everything that was relevant to what I was thinking about at the time. I even went through and I typed it all out, right? All those passages into a separate document. And I reduced a 340-page book into 10 pages, which I could keep in my desk drawer. And whenever I was writing, my papers, I could just say, that idea. Yeah, I got 3 quotes on that, right? They're all in my 10 pages. It's very easy to go through 10 pages, right? And so it's like you've digested the book and you've thrown out what's not important and you've kept the most important things. For this reason, if you look through some of my own personal books, I could grab one on the shelf that I've read many times, you'll find annotations. Here's a book I read all the time. It used to be part of a hardback book, but I tore it out, right? So I just have that one thing, and you see all these things. There's notes on every single page, little tabs, whatever. I keep this here at the side because it's a project I'm working on, and I've been working on for a decade about. So this is the kind of thing I do, and what you'll notice, maybe not somewhat in this one, there's a lot of notes, right? There's a lot of annotations, but also at times you'll see strike throughs, whole paragraphs, right? There's a line through it, telling myself that that's probably never going to be worth my time to read again, right? Because this is one of the things you'll learn in education, is one of the things about intelligence is being able to use your time well and to focus your attention on the things that matter, because there's so many things that don't matter, right? And so annotating, it's a skill, but it's a very, it's very nice because later it really helps you get to the heart of what's important in a text. The practice saves you a lot of time in the future when you're studying for an exam. There are going to be large parts of this text by Copernicus that you should read over once, but you'll never need to look at again. And when you read them, you'll notice that. You'll be like, oh, this doesn't seem so relevant to what we're talking about. Well, then put a line through it, right? Tell yourself in the future when you look at that page, oh, there's nothing here, right? Go to the next page or whatever. Now, of course, those things always have to be revised, and maybe you read the book in the future with a different goal in mind, with a different question in mind, and those paragraphs might become important, right? But in this case, you just got a PDF, so you can mark it up however you want, all right? Books are tools, whether they're PDFs or paper copies. They're not sacred things, right? Unless they're a sacred text, right? They're a tool you can buy. I have like multiple copies of some books because I've torn them up, right? Written in them and so on. So that they're just paper, right? It's just a tool. So if you look at my copy, already you'll see that. I open my PDF in Adobe Acrobat, right? I have an advanced version, but you can all get Adobe Acrobat for free in Adobe Acrobat Reader. And it comes with all these annotation tools, right? So you can just open, these aren't automatically open. You have to maybe open a panel, right? And you get a highlight, a pen, an eraser, you can strike through, you can highlight, you can change the colors of your highlights by doing this. So if you highlight something, then if you click here, I believe you can even also change the color of your highlight if you like. You can use different colors of highlighting. You can use sticky notes, and you'll have these comments on the side. All of how you use these tools is really something that over time you'll develop, right? Like there are certain things you can do. For instance, sometimes in my text, when I find an argument, like there's something that someone thinks is true and then they give the reason for why it's true. I'll like make the statement that they think is true yellow and the reason they give for it green, right? Because I like to see how they build up their arguments. Or maybe if they say there are 3 reasons for this, I make little 1, 2, and 3 where they discuss them, because good writers leave signposts, right? They tell you, I'm going to talk about 3 things, and then they talk about 3 things, right? But sometimes if you don't think, they're talking about 3 things, there's the first thing, there's the second thing, there's the third thing. Third thing might be 2 pages away, right, before they get to it. And so if you mark, here are the 3 things, this is where the first one starts, this is where the second one starts, this is where the third one starts, that's very helpful, right, in the future. So sticky notes. Now, let's go a little further in the text. You'll see sometimes authors, they start with a topic and then they pick it up after they say something. They have a digression, they talk about something else, and they return to their main point, right? That's why there's an arrow here. I've got lots of sticky notes and things because I'm teaching, so I want to have everything well laid out. These are certain points. If you have an advanced version of Acrobat, you can use bookmarks, which are very helpful. Each of these numbers is marked to a bookmark. So if I push here, it takes me to Bruno, right? But if you have the regular version of Acrobat, you can't do that, unfortunately. Let's see what other things. A bit later in the texts, I changed, made little boxes with a summary of what he's saying in that point, right? This is what annotating is. But you can do it, you should do it whatever helps you most, right? As far as me grading your annotations, some students, you're not going to get a good grade on annotations if you just highlight everything, right? Like you right click, select all and highlight. It's all important. It's not going to do it. But how specifically you annotate, that's up to you, because this is a tool for you. I want you to learn how to do it. I want you to develop how you do it. You can do it with, hopefully you'll do it in other classes as well, other documents, once you've come up with your own style. Everyone will have their own style. In fact, as I was going through here, I changed how I did it. You'll see, depending on what worked best for me. So on that, it's kind of like a good effort grade. I see that all the texts that we read, you annotate, and that you annotated them in a way that looks like it would be helpful to someone to later go through that text. And you'll notice with certain, like later in the Copernicus text, let's see, there's no annotations, almost none here, right? That kind of tells me all that text that's not colored or anything, I'm not going to really look at it again if I don't have to, right? I've already judged that it's so I have in a way already reduced this text down quite significantly. And I know the first few pages of it are really important. Yeah. Anyways, questions on annotating. And here I have an arrow, just tells me to bypass all of this, right? And to go down to here, right? So for the lazy among you, that should be good news. This is a tool for the lazy. Although maybe the smart.
I have a question.
Yeah, go ahead.
If we did all of the annotation and we saved it and we sent it to you, you already have access to them, right? So we don't have to give you anything special to.
Yeah, if you put your reader in the Dropbox folder, and whenever you read it, you just double click there and you open it from there, and you always save it, then you have to do nothing to show me your annotations. I will see them automatically. Yes, good question.
I have a question.
Yeah, go ahead.
I didn't like I annotated the reading as I read it, as I went through it, but I didn't have anywhere near as many highlights and underlines and sticky notes as you do. Like I highlight whatever I thought was important. I underline whatever I thought was supportive of the main idea.
Yeah.
Or the but I didn't have that many highlights. Like I feel like
Okay.
mine compared to yours is very like empty. Would that like?
So the good question. First of all, notice because I'm teaching, I perhaps have a bit more than you. That's understandable. Also, I know this text a lot better than any of you will ever know it. So I've looked at it many times, and I have a lot of thoughts about it that just you won't have, right? So sure, you are unlikely to have as many annotations as I do. I would, however, encourage you to do more than basic highlighting, right? There are other tools available.
Like, I personally usually always.
I didn't hear the last part of what you said.
I personally usually always annotate whatever I'm reading.
Yeah, good. Well, that's good.
I usually but like I only annotate whatever I think that when I'm reviewing or when I'm studying for an exam or whatever, or writing a paper about the topic, I might need to use. So like I only annotate whatever I think I can use later on, or I'm gonna be asked about later on.
Sure, exactly. That's what you want to do.
Okay. Oh, okay. Okay.
You're not going to annotate everything. I didn't annotate everything, but some things
Okay.
I intensely annotated, right? Some things are very closely, and there's little numbers in here, 1, 2, right, and so on. Some things are very intensely annotated, and some things are not annotated much at all, right? And that's because, like here, these probably aren't even very important, right? Like this basically tells me I don't need to read this again, probably, right? And I don't need to talk to you about it, probably. As long as you read it through once, there's probably nothing I need to comment on there. But just let me reiterate that point. I do encourage all of you to go beyond basic highlighting, right? You'll find that there are many other things you can do. And sometimes they'll be surprisingly helpful. Like particularly when teaching, for me, having these little notes, even a question, right? Like what is the question he's asking here? Is very useful because it says, oh, this whole section is about that, right? It's like a one-line summary that very quickly allows you to see what everything was about there. Now, I don't want to go too far on this. Any other questions about annotating? Otherwise, we're going to turn to the exciting material for the day. No other questions? Nicholas Copernicus. Let's see what I have on my. Is it here? Here we go. Okay. All right then. Well then if questions occur to you later, just let me know. All right. So this is I guess you guys learned some things about Copernicus in the videos. Yeah. What first question here you can see? Copernicus who? What do you guys know about this guy?
I know that he's a mathematician and an astronomer that said that the sun was the center of the universe, which kind of went against what other people thought, which was that the earth was at the center.
Okay. The view that the earth is at the center is called the geocentric model of the universe. The idea that the sun is at the center is called the heliocentric model. So Copernicus defended the heliocentric model, correct? Is the heliocentric model true?
It is at the center of our solar system, but not at the center of the universe.
Yeah, so the heliocentric system is actually false. In other words, right? So he was wrong, but he was maybe not as wrong. So it's a complicated. We'll see. The history of science and understanding Copernicus is a complicated story, because probably many of you think, well, oh yeah, he's right, right? It's just, the sun is the center of our solar system, but Kinda said it very precisely and very correctly. That was not Copernicus's view. His view was that the sun was at the center of the universe, which is false, right? He also thought the sun was not moving, but the sun is moving immensely quickly, right? And we're just moving. I'll show you a video later in a few classes that actually shows how we're moving probably relative to the center of the universe, which is this huge thing we're spinning, right? Mathematician, scientist. Okay, when did he die? No one look and try to tell me. There's one date in this course.
1543.
Okay. Did you look?
No.
Okay. Now I know who's not telling the truth. No, okay. Yeah, okay. 1543. 1543 is, if there's any date that you remember in this course, it would be 1543, the death of Copernicus. It's a good kind of place to start measuring where we go in this course and where we are, right? It's much earlier than probably many of you were thinking, right? 1543, goodness, it's like, that's a long time ago. But in 1543, things were, people had already circumnavigated the globe, right? Discovered the Americas. Lots of stuff was already, the Protestant Reformation had already taken place. This break between the Catholics and the Protestants had taken place. Europe was kind of torn between Catholicism and Protestantism. A lot had taken place socially that kind of, the Renaissance was is the end of the Renaissance, right? Beginning of what we call the modern period, the Reformation and the modern period. 1543, he died. I think he had a stroke, I believe. In any case, he was on his deathbed for a while, kind of not able to think. What about let's talk a little bit about what you've heard about his views on the universe, right? What was astronomy like before Copernicus, do you think?
It was basically, it put like the Earth at the center of everything. Like, for example, the geocentric model with Ptolemy and Aristotle. They just, for example, for Aristotle, it was that his model was not able to explain like the retrograde motion of specific stars. So that's why Ptolemy came. He kind of, I feel like he did keep the same geocentric model, but he gave an explanation to that retrograde motion. So it was definitely not like giving attention to any other planets or stars other than the Earth at the center.
Okay. So people's view of the universe, importantly, people didn't believe the world was flat. That's a new thing. Anyone who was at all bright knew from early ancient times that the Earth was round, and even had some estimations about its size, right? You go back in very ancient stuff and you get some kind of myths and Plato and other things about different things, but any astronomer worth their salt, all the way back in Plato's times, the Earth is round. Its size is approximately known. We'll see in Copernicus's text that there's lots of everyday evidence that you can use to tell that the Earth is round, right? Like its shadow on the moon is round, right? And you know that it's not a flat disk because no matter where in the month the shadow is always round. It never becomes anything but round. But if the Earth was a round disk, then as the sun, Earth, the moon moved around it, the round doesn't look round from the side. It looks like an oval. So the shadow on the moon would be turn into an oval, but it doesn't. So the Earth is not only round, but it must be a sphere. You can just see this by looking out every night and seeing its shadow on the moon. Sailors, or you can go out to the coast here, right, in Beirut, and look out. And if you see a ship appear on the horizon, the top of the ship appears, and you can see the top of the ship before you can see the bottom of the ship, right? So as it comes over the horizon, you see the tippy top of the sail, and then you see more and more and more of the boat, indicating that as it comes towards you, the earth is curved, right? Even the water is curved. You can see this in everyday experience. If you were, as the ancient astronomers did, smart enough to, or they were, to take, a sundial. You all know what a sundial is? It's this thing where you use it to tell the time by the shadow. And you look at your sundial at noon in different places, you will find that its shadow changes. If you go to Egypt, if you do it in Lebanon, the shadow will be a certain length at noon, whereas in Egypt it will be a slightly different length. And if you go various places, and if you took all those measurements as the ancients did, you would find that it's a very good way to understand what happens to the length of that shadow on your little dial, is that you're on a curved surface, and as you move, and the sun is out here, right? So as you move, its shadow changes depending on where you are on the earth on a round ball, right? And from that you can calculate the curvature of the earth. You'll even find there's one place near the equator where there is no shadow at noon on your sundial, which apparently is very weird. I don't know if any of you have seen it. I haven't, but apparently it freaks people and animals out because things are supposed to have shadows for us. But if you're at noon on the equator, the sun is directly overhead, so nothing has a shadow at that moment, right? So you would see all these things. The ancients did that. So the ancients weren't dumb, especially in astronomy, but they didn't think that there were aliens, right? Their view was that, things out there are not habitable. They're eternal. They don't change. So they can't be lived in because they don't have water and earth and all these kinds of things that we have down here. They're more or less made of a different material that doesn't change. And that material is special in that, like some subatomic particles we know of and other things in a field, their natural way of moving is rotation, right? That's their natural way of moving. Everything on Earth goes in straight lines, and it has a place that it wants to go. But everything in the skies, in fact, everything at the moon and above, that's called the superlunarary sphere. Everything above there naturally, eternally moves in circles, right? And it's better, it's more perfect, it's more divine, closer to what God is like, right? Although they weren't Christians, the ancient Greeks, they believed in a God that was kind of only concerned with himself, not a personal God that cares about human beings, but a God that just thinks his own thoughts and is completely out of touch with the universe and didn't create it, right? But the rest of the universe loves this being. This is Aristotle, right? And out of love, it strives to be like this divine being. So what would it be to be more like God for the ancients? It would be to be more eternal, more permanent, to be unmoved, to be constant, to be steady, to be less visible, and so on, right? This would be what it'd be to be more like God. Okay, so also, as mentioned, there were two names, right? Aristotle and Ptolemy. Astronomy is a complicated thing. Aristotle had a kind of view about what kind of thing astronomy was. And this view was very important and very influential all the way up to Copernicus's time. The view was that there's all of science, right? All the sciences. And at the top of the sciences, you had philosophy and this thing called metaphysics, right? And under that, you had the sciences, and one of the sciences studied the way things change in nature, and that was called physics, right? You had another science that studied the structure, you might put it this way, the structure of things as abstracted from physical things. So just their shapes and geometrical features, right? That was mathematics. It studied the forms of things separated from the physical matter of the things. So if you had a bronze sphere, a physicist would be interested in the bronze and how it melts and that it's falls towards the earth and so on. A mathematician would not be interested in any of those things. They would be interested in the shape of it, the properties of spheres and so on, right? And so you had mathematics and you had physics. And these were two separate fields. Where do you think astronomy was? Any guesses?
In between. In between.
Okay, that's one of three
Took
possibilities.
a bit from both. Took a bit from both. Like they looked at the shape of planets, but at the same time they were curious about what made them.
Okay,
What?
it's an excellent attempt. Yeah, and this is why it's good to cover this point. We'll see it's very influential in the text we're going to read. That was not Aristotle's view. Why not? Sounds reasonable. His view was that astronomy falls under mathematics, right? Not under physics, and not between the two either. Physics, its goal was to give real, what he called natural explanations for why things move and change in the way that they do. Mathematics, and that physics, if you took a course in Aristotelian physics, you would notice there's no mathematics in it, right? That seems strange to us, but he would talk about the kinds of things. So when you wanted to give an explanation, and I explained this in the video, I know, so I'm not going to cover it very quickly. When he wanted to explain why things move in the ways they move, he always appealed to the kinds of things they are, the sort of matter they're made from. Why does air move as it does? Because it's, well, that's one of the elements, and it has a certain typical way in which it tends to move. Earth is one of the elements, so it has a typical way in which it tends to move. If you mix earth with air, then you might get more complex motions, right? Because you're combining two different things that have two different characteristic ways of moving. But that's a natural explanation. Keep that in mind, because in a lot of the texts, it's gonna use this word natural explanations, physical explanations. This is what they mean, right? Giving a real reason why the thing does what it does. And Aristotle's view was that mathematical reasons are not natural explanations. So the mathematician, when they draw up a model of something, is not explaining why it does what it does. They're simply describing it, right, in a certain way. They're just talking about the structure and not about the reason why it does what it does. So the astronomer, so this is very important, because what it means for astronomers is that their goal, their purpose, is not to explain why the planets move the way they do, or even to discover how the planets actually move. The goal of the astronomer is to create a mathematical model that will allow them to calculate the positions of the planets in the sky at certain times of the day, certain days of the month, certain months of the year. So their goal was to create a calculator, right? A mathematical method for calculating these things. That's it. That calculator did not and was not intended to actually correspond to the structure of the universe. All it had to do is work, right? So, you know, like my computer, I can use my computer to calculate where the moon will be December 26th, 2055, right? Where in the sky it will be. My computer is going to do that in some really complicated way that has nothing to do with why the moon is going to be there, right? It's going to tell me perfectly. But it's, you know, a bunch of electrons going through little logic gates and stuff in my computer, following an algorithm that is in some way related to the theory about what the moon does and moves, but in no way explains it. In the similar way, astronomers, their goal was to create such a model, right? Ptolemy, so this is where Ptolemy comes in. Ptolemy was simply so you could, from this you can see that the goal of the astronomer is a very technical one. Right? They often worked for a king or a patron or someone. They basically had two roles throughout history to do astrology, right? They made a lot of their money on the side doing astrology, of course. Even people like Copernicus and others Kepler was a famous astrologist. Right, he was very happy to take the money of princes and kings to tell them stuff he knew wasn't even true. But the other thing was often to work on predicting the seasons, you know, determining the dates for the crop harvests and so on, working on calendars. Calendars were of a lot of interest throughout history. Some of you are aware, we don't, it's always a surprise to, especially to Westerners who grow up in the United States or somewhere, when they move to somewhere like Egypt and they realize that holidays actually sometimes depend on someone seeing stuff in the sky, right? You've got, like in Islam, right? There are certain holidays that only begin when the moon is seen, for instance. That role of having people who observe the sky in order to determine when holidays and when religious occasions are, that's a long historical thing, right? And that is one of the reasons there have always been astronomers around, and they've been paid, you know, money for food to eat, is because they are very important for these purposes. No one wants to find out that they're celebrating the religious holiday on the wrong day, because that could lead to problems, right? You have to be as strict as possible. So these are the other kinds of things they would do. They were important for calculating when to do certain things. So they had a very technical job. Precision was important to astronomers, and Ptolemy was the best of the best, right? He lived in the hundreds, you know. He was well after you know, Aristotle and Plato and all that stuff. He came quite a bit later, but he had no telescopes. He just used what was called naked eye astronomy, right? But it's not as basic as that, because they did have lots of instruments. In fact, he went to the deserts in Egypt where you have these beautiful skies, right? And he built these enormous machines that you use where you have, the larger they are, the more you can measure, for instance, the angle of a star in the sky. So if you take like a, you know, like a protractor, if you get like an enormous protractor and you put a tube on it, if that tube's very long, you can use it to very precisely measure the angle at which a star is in the sky, right? And this is how they would measure, this is what a lot of astronomical data would be. You would have this thing called the horizon, right? And then you would have the angle upward was a measurement, and the angle this way, right? The direction. If you have those two things, time of day, the two angles, you can identify, that's all you need to kind of fix where a star is or where it will be, right? time, and those two things. So that's what they would measure, right? And his measurements were the best for the next 1,000 and some years. Even Copernicus used Ptolemy's measurements. And he wrote a book called the Almagest and several other books in which he essentially found, was the guy in astronomy for a couple thousand years. In doing that, he built this model that I talked about in one of the videos, right? This very complicated model, because he had this idea. So his goal was to be able to predict the positions of stars in the sky at different times of the year, right? And he had this idea that however you're going to build a model to do that, you need to do that using circles. And he would, put the Earth in the middle because it seems to be in the middle, right? Because if you go out at night, don't the stars all look like they go around us in a circle? It does. Try to explain that some other way. It seems like it's because we're in the middle and they're all rotating around us. It looks like it if you go outside. So he puts that in the middle. He puts a circle for a planet. He tries to fit the data to that circle. The data doesn't fit. So he did something. He did that for the moon, and the data didn't quite fit. So he moved the Earth a little out of the center of the universe in his model, and the data fit better, right? It fit really well, in fact. This is why his model is called the eccentric model. It's not actually a geocentric model. The Earth is not in the center of Ptolemy's model. It's slightly out of the center. Why? It's ugly, right? Isn't that ugly, Raymond? The Earth is just out of the center of the universe. But because the goal was to fit the data, right? You'd say he's a good scientist. He wasn't fixated on his presuppositions about the universe. He fit the data, right? And then he tried to put the next planet on his circle. It didn't fit. And then he said, well, maybe it's got to be circles. I'll add a circle to the circle, right? Maybe I can have a circle and then I'll put another circle on that circle. And then I'll try to fit the data to that and change the size of the circle as I need to, both of them, until I fit the data. And it turns out that worked for almost all the planets, doing something like that. Those are called the deferent and the epicycle, right? And then he built his model, and his model was wonderful. It worked so well that there was no measurable error that anyone could find. It perfectly fit the paths of things in the heavens. But under Aristotle's interpretation, that model doesn't tell us anything about the universe, right? It's just mathematics. It's just a calculating tool. That's why Ptolemy felt himself free to add circles however he wanted, because it didn't matter. He wasn't trying to find out what the true structure of the universe was. He was simply trying to calculate where things would be. So that's kind of the status of astronomy before Copernicus, right? Now, although that was the view, like the dominant Aristotelian view, there were still astronomers who were interested in what the universe might really be structured like, right? And Copernicus was interested in both. So that's something to keep in mind. This is kind of the pure Aristotelian view of astronomy, but not everyone had the same view, right? And some working astronomers didn't like the Ptolemaic view. For instance, there's a lot of Arab astronomers that were very important in the Middle Ages. Does anyone know why the Ptolemy's book, the Almagest, was called the Almagest?
The what?
You know why Ptolemy's famous book, which was called the Almagest, is called the Almagest? Why it has that title? It's not a Greek title. Any idea?
It's an Arabic title.
It's an Arabic title, yeah. Because, okay, that's not, but because a lot of the Greek work works were lost during the Middle Ages, but they had been translated into Arabic, and Ptolemy's great book was one of them. So during most of the Middle Ages, it was only there were basically only Arab astronomers working, and they had the only version of Ptolemy's book, so it was called the Almagest, when it was translated back into Latin, much later. If it weren't for the Arab astronomers, it would all have been lost. But they were interested both in calculating and in the nature of the universe. So they were very unhappy with Ptolemy's model, right? Because it makes for a very weird kind of model of the universe. For them, it was particularly a problem because a lot of I don't know if you know this, but the Arab philosophy and Arab science is greatly indebted to Aristotle. But Aristotle's model of the universe, if you remember what that was, it was very simple, right? It didn't have all these circles on circles. It just had spheres, right? With the outer sphere of fixed stars. And he wrote the physics. We'll talk about physics in a minute before we get to the text. He also wrote the physics, and if you wanted the Ptolemaic model to be a model of the universe, how it really works, then it just looks crazy on Aristotelian physics, because there's nothing in Aristotelian physics that would explain why something would move on circles, right? Because Aristotelian physics, it was just things under the moon move up and down, and things out above the moon move in perfect circles, right? They don't move in circles on circles or anything like that. So also this idea that the Earth was not in the center, Aristotle had this principle that all circular motions move at a uniform speed around their centers. I'll explain that a little bit better later. But the Ptolemaic model violated that, and the Arab astronomers hated that. So they tried to change Ptolemy's model in lots of ways as well. So there were others. So point there is that although in the Aristotelian model of thinking in general, astronomy's goal is just to calculate, right? Cosmology is an area in physics about how it's part of physics that applies to the skies. Astronomy isn't. Astronomy is this mathematical thing. Nevertheless, there were lots of astronomers in different traditions who tried to bring those two things together, right? And so we're unsatisfied with either the Aristotelian model because it couldn't explain what happens in the skies, as Ptolemy's did. But they were also unhappy with Ptolemy's model because it didn't fit with Aristotle's physics, right? And so they were very unsatisfied. This is pretty much what tortured astronomers from Ptolemy until Copernicus. It even tortured, we'll see, the young Copernicus. This is where he starts with this problem of these two things and how to fit them together. Now here, I want to just, I said I want to talk about physics for a minute. We talked a little bit about the Aristotelian physics, right? But let's talk about our physics. What do you think people knew about physics in Copernicus's time? Any ideas?
Very little. They believed that things were made out of the four elements, I think, or was that before him?
Well, that's one of the views, yeah. And they had this idea that things have their natural ways of moving, right? In a way, you say, okay, yeah, that's obvious. This is what the professor's already talked about. He talked about the four elements and motion, whatever. But I want you to think of it from the other point of view. What do we know now that we didn't know then? Well, when did Newton live? Anyone know when Newton published his?
1700s.
The end of the 1600s was when
I think
1690s was when he published his great mathematical principles of natural philosophy, right? Did you want to say something?
I want to say something.
Okay.
People at the time, at Copernicus' time and before, they hated physics for one reason, because physics made things very random and it didn't give very much value to where we are, or when physics came, it said that we're not at the center of the universe, and people were afraid of that. So they didn't like physics. That's why when Galileo came, they actually captured him and put him on house arrest for almost, I mean, a lot of time, because they were scared of the idea that we are not at the center of this universe, and that we are not the meaning of everything that's going on, and everything revolves around humans.
Okay, so
That's why they hated physics.
okay, Abdul. I want you to keep that in mind and to see if that corresponds to what we're going to read about. Can you do that for us?
Yes, I can.
Yeah, because I think you will find that that won't be very well confirmed. We'll see. We're going to talk about Copernicus, the reaction to Copernicus, Galileo, but we're going to have to see exactly what was going on there, right? One of the things, and I'll just say it now, one of the things you should look for, just look how much Copernicus talks about the sun being the center of the universe. Although that's how everyone now summarizes his theory, that is not how he understands his theory, right? So we'll see why. Now that's true in his theory, right? That's true. But that, even though that's true in his theory, that's not how he understood his theory, and that's not what he thought was important about his theory, and that's not what he thought would be controversial about his theory, as we'll see. So we'll have to see whether that old story about mankind used to think that they were everything revolved around them, and then got upset when they found out it didn't. Let's see if that works. Now, let me tell you one thing and then I'll go back to the physics question. One thing that conflicts with that, which is the medieval Christian worldview and in the Aristotelian worldview. This is why they kind of worked well together. In Aristotle, all the crap of the universe accumulates in the center, right? Like all the heavy, corruptible stuff. The stuff out there is more divine, right? And the further you go out, the more closer to God it is. This was also the Christian worldview. The earth, the only thing worse than the earth was hell at the center of the earth, right? So as you move towards the center of the universe, you weren't going to a better place, you were going towards a worse place. And mankind should strive as much as possible to release themselves from this place and to be like what is closer to God, right? So it's true that in the old, the medieval model, we were at the center of the universe, but the center was the worst place to be, right? It wasn't a good place to be. This motivated this idea that matter is bad. Physical things are bad. Bodies are the source of why we sin, right? It's the physical part of us. And that we need to release our invisible selves that are more like the beings out in the universe. This is kind of the value system of Christianity superimposed on a cosmological astronomical model, right? And notice it would kind of be nice, and you'll see there are people, we're going to read this guy named Bruno, who thinks that the idea that we're not the center of the universe, thank goodness, right? What a freedom to not be in that terrible place, right? What freedom to not have to hate our own bodies and the physical world around us. What freedom for this is how they put it, and Abdul, this will kind of strike you maybe. Bruno will say, what Copernicus taught us is that the the Earth moves among the stars. It's out there among the stars. So his problem, it wasn't like, oh, too bad we're not the center anymore. It was, thank goodness we're not the center. We're out with everything else that is perfect in the universe, right? So this was the way that we maybe see Copernicus today is quite different from the way people saw it in the period, as we'll say. And it's much more interesting than the standard story, as we'll see as well. Raymond said, yes, over 2,000 years we wanted to live out amongst the stars. Yes, and then we found out that we do, right? Okay, so back to the physics question. So Newton, you know Newton's three principles, right? It's three axioms of physical motion. What are they? Someone want to tell us what the Newton's three principles are? Even if you're not a physicist, these are things you should be aware of.
For every action, there's an equal and opposite reaction. That's one of them, I think.
Yes, every action there's an equal and opposite reaction. Yes, what else?
You mean his three laws?
Yes. These are axioms.
The one about one is about free falling.
No, that you're thinking of Galileo. The first is a principle of inertia, right? What it's often called. Bodies do not change their state of motion unless influenced by a force, right? So bodies at rest tend to stay at rest. Bodies in motion tend to stay in motion unless influenced by an external force, right? In other words, if you were to just send something off in space at a certain velocity, it will never change its direction or its velocity unless something impacts it, right? First law of motion. Second law of motion, F equals ma. Force is proportional to the mass of a body times its acceleration. So you can calculate if I put a force on something, it will accelerate, and how much it accelerates depends upon its mass, right? F equals ma. And someone just stated the third one, every action has an equal and opposite reaction. These are the three axioms of Newtonian motion. To this, and using these, he did a whole bunch of math and a whole bunch of observation, not a whole bunch of observation, some observation, mainly math, and came up with the universal law of gravitation, right? That all matter attracts all other matter depending on a constant, right? Times the masses of the two bodies, all divided by the square of the distance between them, right? That was like the great achievement of Newton, right? Along with creating calculus. That's what a lot of us, probably even you today, that's probably most of what you know about physics, unless you're a physics student, right? Even then, you will spend a lot of time even studying just how to apply those three laws in mechanics and so on. That is not something that existed. So think about it. 1543 is when Copernicus died. That was published in 1697, I believe, right? Well, that's a couple hundred years, right? So the physics of Copernicus's time was just basically Aristotelian physics. They didn't have, and you have to keep this in mind in reading. There's not covering this for no reason. There's no such thing as inertia. He has no idea of inertia. The bodies will continue to move unless deflected by a force. He has no notion of universal gravitation, right? People will, and you'll find in the text the word gravity, right? What does he mean by gravity? Does anyone have an idea? Gravity?
You mean as an English word, or
Yeah, he'll
as a
say
scientific
the
gravity of a matter?
Huh?
Like as an English word, gravity means like the importance or the.
Okay, sure. but he'll use it. He'll say like the Earth has gravity, right? Gravity. What he basically means is like weight. Things have weight. Like everybody knew that, you know, like this book pushes down, right? That's not a theory of gravitation like Newton had. Newton's law of gravitation is that all matter in the entire universe attracts all other matter in the entire universe according to the square of the distance between them, right? That's universal gravitation. The idea that there are bodies that are heavy is something that's been obvious to people forever, right? Aristotle knew that. He had an explanation for that heavy bodies are seeking the center of the earth, right? They want to go down there and they will stop if they got to the center of the earth. And he's right, they would, but he didn't have the law of gravitation. So Copernicus can refer to heavy bodies and gravitation, but the idea that, so for instance, that the moon attracts the earth, well, this is something Copernicus never dreamt might be true. That Jupiter attracts the sun to it. No, never even dreamt of. Not only not dreamt of, but would seem totally absurd, right? If Jupiter attracts the sun, then why don't they fall together? If all matter attracts all other matter in the universe, why isn't it all just one big lump? Why isn't it?
Because the planet's being attracted by many other objects around it, not just by the sun, like by the.
If that were true, then it would still just all.
There's the centripetal force.
You're getting there. You're getting there. Inertia.
The motion stops us from
Inertia.
falling in.
The motion, yes, exactly. So as the moon travels around the Earth, right? The moon is traveling around the Earth. Inertia is carrying it in a straight line, right? If gravitation disappeared, the moon would travel it in a straight line just forever, right? Away from the Earth. But as it's doing that, the force of gravity is continually turning its path, right? You've got two forces, a force towards the Earth and a force perpendicular, tangent.
The tangential. Right.
And
Yes.
you put those two together and you get motion in a circle, right? Using this law of how you add together forces. So notice he had no notion of inertia, so he could never explain how planets could not fall into one another. And so he could never have the idea of gravity either, right? This is often what happens in science, is that you can't have one idea without the other idea, right? So how do you get there? If you don't have the whole picture, you can't even have part of the picture because it's all a system. So keep this in mind when Copernicus is talking about his model and everything, and he's going to talk about physics. He's going to often use Aristotelian physics. And it's good to keep in mind not only the physics of Aristotle, but also how much the physics of Aristotle lacks what you and I take for granted. The kinds of problems that arise for you to say, to make this, for Copernicus to make this change, right? Like things seemed to make sense before, but suddenly to have a heliocentric model like he did, all the physics has to change, but he doesn't have any of the new physics, and he wasn't a physicist. So you have to keep in, this makes very complicated both reading and trying to grasp what the significance is of what he's saying. So do keep that in mind. That's always an exercise. Kind of trying to be aware of what you have to not presuppose when you're reading someone. Okay, we're out of time. That's a good place to stop. We'll start next time right with the text. I'll send you an email because I think I have a quick quiz for you all. Any questions before we go? One thing I want to say is I'm a thinker. I'm not a clock watcher, you know? Doesn't mean I don't want to go have lunch. I do. So, but it just means I sometimes will go over and not notice it. So feel entirely free Just say, Professor, I'm sorry, but it's 12:15. You should go have your lunch. Yeah, and I will do that. So it's not, it doesn't offend me or upset me. I want to end at the right moment. So if I don't, that's kind of partially your fault too. I'll just expect you all are so excited about what I'm saying that you can't possibly break in and tell me. Any questions before we go? I did record this session, so I will be uploading it. Okay, no questions?
Someone asked a question on the chat, sir.
Oh, I don't always see the chat. Is there a deadline to the quiz, Professor? I'll let you know. Of course there will be a deadline. You can't wait till your deathbed moment to take it. But I'll tell you exactly what the deadline is in the email. Yes, you're welcome. Nini, if that's correct. Okay, I'll see you all next time.
Oh yeah, sir. Just do you want the annotations? The annotations, do you want them?
Just do what I asked as far as setting up the Dropbox and putting your folder in there. I'm not going to check the annotations right away until everything's set up. So I wouldn't worry about it at the moment.
Okay, thank you.
Okay,
Have a nice day, sir.
You too. Bye.
Thank you. Bye.
Thank you.
Thank you.
Thank you.